In today's video, we're going to talk about the first topic in section 3, accuracy and precision. This is going to tell us a lot of information about how good a measurement is and whether or not we need to collect more data, keep data, or ignore data. So let's talk about accuracy and precision. Accuracy, think of it like a bullseye. You're throwing darts at a dartboard. How close are you to the center, to the bullseye? That is accuracy. And what we're trying to do in science measurements, and any type of measurements, if we're dealing with accuracy, we're talking about how close are our measurements to an accepted value. Whether that's a standard or some type of other measurement in which there's a universal expectation for what that value should be. Precision, on the other hand, has nothing to do with the so-called bullseye. It has everything to do with how close all the measurements are to each other. So imagine you're in a class. You make a measurement and everyone else in your class makes a measurement. How close is yours to the rest of the class? Because that may lead us to determine whether or not you've got a bad number or other people in the class have a bad number. Down here at the bottom, it's very simple. We have 3 pictures of sort of different targets. And in the bottom left here, we have a target where all of the points are grouped together, but they are not near the center. So we would say that these have good precision because they are close together, but it is poor accuracy. Now, the ones in the middle, they're kind of all around the center. You know, if we're looking here, they're sort of just in the middle there. We would say these have good accuracy. They have poor precision. And the very last ones should be the most obvious. These have good accuracy and precision. So when we make measurements in a lab, we not only need to have an idea for what our measurement should be, but also be able to repeat our procedures to get the same measurement over and over and over again. Another word, if we think of precision, think of repeatability. Can I repeat the same thing over and over and over again? Let's say you do an experiment 10 times. If every time you do an experiment you get a completely different answer, you don't know what's right or what's wrong. So hopefully we're able to not only repeat what our measurement is, which gives us precision, but also hopefully our measurements are near what the accepted value is. Now, how do we know how good or how bad a measurement is? How do we calculate that? How do we describe it? How do we determine it? Basically, it comes down to a couple simple calculations. And your book really only shows one, but we're going to go through 4. The first one here is called absolute error. Simple symbol, E sub A. Very simple calculation. E sub A is equal to O minus A. O is your observed measurement, what you measured in class, and A is the accepted value, what you should have gotten. A standard, an accepted value, what you're expecting to get. It's a simple value. Whether the number is positive or negative tells you whether or not your measurement was above or below that accepted value. And we will do these, the first time we'll really look at some measurements or some values is when we do the density lab with pennies, which you will do very soon. And we will do these calculations for all of those measurements. Now, that's kind of good, except if somebody says, well, my E sub A was 0.1. Somebody else says, well, my E sub A was 0.01. Who's better? We don't know. Because, well, you might say, well, the first person's worse. Well, not necessarily, because we're talking about a bigger number potentially that they're off. What if everybody, what if your number was supposed to be a very, very, very small number? and you are really, really far off. Okay? So we have to be very careful when we determine an absolute error. Just because it's a small number doesn't mean that that's the best, because you have to take into account what were the measurements. So a better way to calculate this is what we call percent error, or relative error, which is E sub r. You can see the very simple calculation here. O minus A, so the difference between the two measurements, divided by the accepted, times 100, gives us a percentage of error. Or you can see down below, E sub r equals E sub A divided by A times 100. That is the best way to characterize whether or not a measurement is accurate or not accurate, is by doing a percent error calculation or a relative error. Again, a negative percent tells us our measurement was below the accepted. A positive percent tells us our measurement was above the accepted value. This is the only one calculation that's in the book. And they have it set up a little differently. This is the easiest way to remember it, and this is the best way to remember it. All right, so we talked about accuracy, hitting the bullseye. Well, now what we want to talk about is precision, the repeatability of a measurement. We just want to keep doing the measurement over and over and over again and get the same number. So when we talk about precision, how do we account for that, and how do we determine whether or not something is precise? Well, the term we're going to use is what's called deviation. How far does it deviate from everyone else? And to quantify what does everyone else mean, it's the average or the mean of all the measurements. So you take 10 measurements, how far off is measurement number 2 from the rest? How far is measurement number 4 from the rest? So the first thing we do is what's called absolute deviation. And again, you can see it's a very similar equation and a calculation to absolute error. Absolute deviation is the difference between your measurement and the mean, or the average of all the measurements. You subtract, that's how far your measurement is off from everyone else's. It's a good piece of information to know. Again, though, not the best way to describe precision, because it's an absolute value. Somebody could have a difference of 0.1 and a difference of 0.01, and that doesn't give us the best picture in terms of who is more precise and who is less. What is the best is relative deviation, or what's referred to as percent deviation. Here, this gives us the best picture in terms of the precision of a group of measurements. What do we do here? As you can see, very similar, relative deviation or percent deviation, very similar to relative error, percent error. It is, again, the difference between your measurement and the mean divided by the mean times 100. If you remember, relative error, percent error was O minus A divided by A times 100. Well, here it's O minus M divided by M times 100. Relative deviation, again, can be written dA divided by M times 100. So you have 4 equations that we can use to be able to describe how accurate or how precise a measurement is. Be able to determine whether it's a good measurement or not a good measurement. The 2 we want to focus on the most are percent error and percent deviation, or we can use the term relative error and relative deviation.